Hello guys, welcome to our channel, the YT University, and today in this video I will be doing a graph of the periodicity of properties of elements in the periodic table. So it's a different kind of graph because I want to compare, like say for example, what happens when the atomic size increases and what does it do to the ionization energy or something like that. So I want uh, a clearer picture, and this needs a skill on another level. So we're going to use Python for this. So I have a sample code right here, but you have to install the prerequisites before you can run this. So I'm gonna walk you through on how I created this sample program. So for this purpose, we're going to install Seaborn, okay? And you're going to need the access for your command prompt. So I'm gonna type cmd and I'm gonna open command prompt. It's different for different operating system, so be sure you're familiar on how to open this. You just have to type the installation code here, pip install matplotlib pandas seaborn, and then click enter. What's that? There's an error. This package do not match the hashes from the requirements of the package version to update the hashes, otherwise it's on. Okay, we have to follow the instruction. Okay, so it says here that it is successfully installed. Now to graph the data from Excel, you need another library. It's called OpenPyExcel. Alright, we're going to install that. See, um, successfully installed. Okay, so if it is successfully installed, you can now start coding. But sooner or later, you'll find out that the periodic table, which is used by Python, is not complete. Okay, there's still information that you need to append. Okay, so for customization purposes, I'd like to use Excel, as I've mentioned a while back. Okay, so I downloaded an Excel file that contains the information of the elements. So this is my periodic table in Excel format. So you can actually download this from www.vertex42.com. So Excel templates here. So I'm going to get this link and put it in the description box below, so you will be able to access this same document. Okay, so this is the data. It's complete. As you can see, it has the atomic number, name of the element, the symbol for the element, atomic weight, and up to its year of discovery, okay, and who discovered it. Okay, so technically it's comprehensive. So if you're going to graph this, you'll be needing a big graph, I can say. All right, so we'll not be exhausting all of the elements. There's 106 of them. Okay, it's a big graph, so we're gonna use maybe at least 18 elements. Okay, so up to argon here. Okay, let's start. So I'm going to generate a new sheet, and I'm gonna name it 3D periodicity, because I'm going to relate the size, the atomic radius, to some properties like electronegativity, electron affinity, ionization energy, and so on and so forth, atomic number, Um, yeah, so to be able to analyze the connection between the atomic size and this properties, so you'll find out later. So I'll be needing a column name. Let's say, for example, um, element or name of the element, like element underscore name. Alright, so you have to be very careful on your naming because Python is sensitive, okay, and it has to be able to access the uh, column name for it to be able to graph it, okay. So you have the atomic number here, so it's a whole number. It is the number of the protons that an element has. So more of that in some of our other videos. So right now let's focus on graphing, okay, and then group or period. Okay, so using the period, you can easily locate the element. Period 1, 2, 3, 4, 5, 6, 7, and then group. Okay, the group says there are 20, group 1, group 2, 18 groups, I think. Okay, I'm not sure. Yeah, I'm going to review later. So using this tool, you'll be able to locate the element and basically know what is the valence electron, ionization energy, and so on. Oxidation states, I mean. Alright, so using this tool, and you can predict the or some physical characteristic, whether it be metal, liquid, uh, or gas. Yeah. So, and one property that you need to know the most or is the atomic radius. Okay. And then let's say, for example, I'm gonna put the ionization energy. Yep, underscore energy. So these are the things that I need for my graph. So let's just do group 1, okay, or group 1 and 2. So no, periods 1 and 2, I guess. Okay, so let's go back here in the periodic table. So this is group 1. Okay, this is group 2. 3, but you see here 4, 5, 6, 7, 12 until 18. Alright, so there are 18 groups. So we're going to do periods 1. So this is period 1, this is period 2. So that is composed of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 elements. Alright, so we'll start with hydrogen and then end up with neon. Okay, so let's see the data. So it's in here, neon. So this 10. Okay, so I'm gonna copy the name of the element. I'm gonna put it here. So yep. You can just use this data if you want to, but for demonstration purposes, I want it this way because I can pick. Okay, I can pick which element is to be graphed. I can compare. So it depends on your purpose. It depends on the lesson. I say it's group 1 and 2. So this is group 1, and the rest belongs to group 2. Okay, that's how you do it. So you can check. Now here comes the tricky part for the groups. So this is period 1 and 2. I think I'm mistaken. Alright, so let me clarify that. So this one is for period 1. Alright, period 1. So hydrogen and helium falls to period 1 or belongs to period 1, and lithium, beryllium, boron, carbon, nitrogen belongs to period number 2. Okay, so yeah, there you go. And then for the group, we just copy. So this is the group. So it's easier if I'm gonna grab this one. Okay. So there are 18 groups. Okay. So the count would start from 1 to 18. Okay. So atomic radius, we're gonna look for that. It has a unit. Where's the atomic radius? So you see here, atomic radius. Okay. Uh-huh. So it has a unit. Let's just get the atomic radius using the calculated. So this one, so until, because it has a unified unit, okay, picometer. So that's what you mean by PM, okay. All right. So yeah, and then we'll get the ionization energy. Going back here. So ionization energy is the energy required for you to get the electrons. Okay, so 13.5 electron volts. So 13.5 volts is required for you to pull one electron. I think it's a mole of electron from 1 mole of hydrogen, something like that. If I'm mistaken, then let's just go back when we have lessons in chemistry. Okay, so I'm gonna put it here. Okay, so let's see the behavior of group 1 or period 1 and 2 of the periodic table when it comes to their atomic radius and yeah, the ionization energy with respect to the atomic number. Okay, yeah, so it depends on what you want to learn and explore when graphing. Okay, so this will be the final code. Okay, you can modify it in any way you want. Okay, so for this demo, I'm going to use the atomic radius to be at the x-axis. Okay, and the y-axis will contain the ionization energy. The z-axis will contain the atomic number, and I would want my graph to have a label which would be the element name. So you can change this to the element symbol if you want to. You can also change the size of your graph. You can make it bigger or you can make it smaller, depends on your preference. And what else? Alright, you can change the name here. You can change the labels if you want to. Yeah, so everything is editable. Okay, let's try to run this code. Okay, I'm gonna click the run button right up there, and we have a beautiful graph, and we're going to explain this as soon as we have our chemistry class. So yeah, so you can rotate this, okay, and you will see that if you're sharp, okay, you can figure out the relationship between ionization energy and atomic radius. Okay,